This is John Black, super chemist. First, let's define formal charge. It's the charge assigned to any atom or molecule, assuming that the electrons in all the bonds are shared equally between those two atoms, right? And regardless of relative electronegativity. But here's the formula. Formal charge equals group number minus non-bonding electrons minus bonding electrons divided by 2. First, I'm going to show you how to simplify it into this formula, right? And the only thing I'm changing is right here. Bonding electrons divided by 2. Now, my whole point is this. Why count up the electrons in this bond and divide them by 2? You know there's 2 of them in there. If you divide by 2, it's always going to be 1, which is how many bonds there are. There's 1 bond there, right? There's 2 electrons here, not bonding electrons, right? So if I divide that by 2, 2 divided by 2 is 1. And how many bonds are there? There's 1 bond. So why count up the 2 electrons and divide by 2 when you already know it equals a bond? That's why I say just change it to how many bonds there are. Bonds. See here, bonds. Instead of saying bonding electrons divided by 2, we're going to say bonds, all right? Because that's the same number, right? I'll tell you what each thing means. Group number is if you look on your periodical chart, right, the vertical lines that go up and down, those are your groups. I don't want you to look at this and notice. These are the group numbers. Carbon, nitrogen, oxygen, fluorine, neon, group 4, 5, 6, 7, 8. See how it goes up? That's how the periodical chart looks. And basically that tells you how many electrons, right? If you're in group 6, that means, oxygen has 6 electrons in its valence electrons. If it's in group 7, like fluorine, that means it has 7 valence electrons. So basically you just want to know what group number or how many valence electrons it has, right? Because that's the same thing, right? Non-bonding electrons are the electrons that are just, they're lone pairs. See, like here on the oxygen, these 2 set of lone pairs, those are your non-bonding electrons. And then your bonds, obviously, are your bonds. You know what your bonds are. So let's do an example here on this H2O. Let's find out the formal charge of oxygen, okay? Oxygen has group 6, right? Right there, group 6. How many non-bonding electrons? Let's see. 1, 2, 3, 4. So that's 4. How many bonds does it have? Well, let's see. 1, 2. So that's 2. 6 minus 4 minus 2 is 0. So what's the formal charge on this oxygen? 0. Let's do the hydrogens. You can see the hydrogens are identical. So whatever one hydrogen is, the other one is 2. What group number is hydrogen in? It's in group number 1. How many non-bonding electrons? You ain't got any, right? So 0. How many bonds? So there's 1 bond there. So 1 minus 0 minus 1 equals 0, right? So the 2 H's have 0 formal charge and the oxygen has 0 formal charge, okay? It's that simple. All right, now let's do nitrate anion. Now this overall anion has a -1 charge, right? So let's do the nitrogen first. It's from group 5. How many non-bonding electrons? 0. How many bonds does it have? 4. So it's a +1. Let's do this top oxygen. It is in group 6, so it has 6 valence electrons minus the 4 lone pairs, non-bonding electrons, minus the 2 bonds it has. So it has no charge. Each one of these down here, as you can see I did it twice, should have 6 minus the 6 that they have that are the non-bonding and 1 bond. So they each have a -1 charge. Overall, the whole molecule, +1 and 2 negative ones, it's overall a -1 charge. So this is all good. A lot of people, they just memorize how many bonds it should have. And the way they do that, right, oxygen, you obviously would think of water. It's H2O. Oxygen wants 2 bonds. But why does oxygen want 2 bonds? You know what I mean? Looky here. This is the number of bonds that you need to be neutrals. Carbon needs 4 bonds to be neutral, 3 for nitrogen, 2 for oxygen, 1 for fluorine, 0 for neon. I want you to notice how this is going up the groups, and this is going down on the bonds that you would want. But notice how they all add up to 8. 8 plus 0 is 8. 7 plus 1 is 8. 6 plus 2 is 8. 5 plus 3 is 8. 4 plus 4 is 8. That's how you know how many bonds that these elements would want to be connected to, how many bonds they want to be neutral. You just add it up. I mean, if it's in group 5, I'd say it would want 3 bonds. If it's in, you know what I mean, to add up to 8. To fill its valency. That's why that's why oxygen wants 2 bonds. It wants to fill its octet up to 8, and it only has 6. Okay? So you can just look at a molecule and know which of the atoms are, positive or negative on a formal charge. If there's an extra bond, it's positive. If there's minus a bond, then it's negative. And let's look at oxygen, water, for an example. Here you have an extra bond. It should have 2, right? Because it has 6 valence electrons. 2 more it needs to have its octet full. But it has 3, right? Why does that make it positive? Because remember, there would be 2 lone pairs here, right? A proton must have jumped onto one of those lone pairs and formed a bond, right? It took both. The oxygen donated both the electrons, right? So now it only, you know what I mean? Now down here, why is this negative? It needed 2 bonds. Remember, this lone pair here wouldn't be there. It would be a bond, right? Now, something positive like a proton jumped off, because this used to be an alcohol. A proton jumped off but left both electrons. Now that's why it is negative. See, it lost something positive here. It's gaining something positive that has no electrons. The proton had no electrons. So the oxygen gave some of his electrons to the hydrogen, making the oxygen positive. Okay? You can use formal charge to figure out whether a structure of a molecule is correct or not. Because the structure chosen is such that the formal charge on each atom is as close to 0 as possible. And I'm going to give you an example. Let's say we're talking about CO2, right? You may know that it has 1 carbon and 2 oxygens, but you may not know how it's linked up. So here are 3 examples of the way it can be, right? And then I did the charge for the first oxygen, the carbon, and the second oxygen. They have to add up to 0 for it to be correct. They all do. Okay, I already did all the math. Like carbon is in group 4, so it has 4 electrons, and it does have 4 electrons. So how do I know which one is right if they all add up to 0? Well, look at them. This is, which ones, these are all zeros. So they're the closest to 0. Remember, we got to get close to 0 as possible for it to be correct. And if these are the 3 examples you can have, these are the ones that are all zeros. So you can't get closer to 0 than being 0, right? So obviously it's this bottom answer here with the 2 double bonds. Alright, now a good scientist would learn that equation and that would be the end of it. But I want you to understand what that equation means, right? And here's the equation again. Formal charge equals group number minus non-bonding electrons minus bonds. I want you to look. Here's an example of oxygen. Here's group 6, right? What group number is it in? It's in group 6. That means it has 6 valence electrons. See how I have 6 electrons around that oxygen? This is a free radical, and some people think a free radical is very reactive because it is positive or negative. That's not true. It's reactive because it doesn't have a full octet. Okay. It's actually neutral. Okay. All free radicals are neutral. Okay. It has no charge whatsoever. So that's why this formula is here, right? You go to the periodical chart and you see what group it's in. It's in group 6. That means there's 6 valence electrons. So that means 6 electrons, and that means it's a free radical, which means it's neutral. So if an oxygen has 6 electrons as neutral, then all you have to do is look at this and say, look, this has 2 lone pair there, 2 lone pair there, and it donated 1 electron to each of these bonds. So that's 1, 2, 3, 4, 5, 6. It has 6 electrons. And we know that it's in group 6, so 6 electrons is neutral. We don't have to do the formula. We just have to know that group 6 has 6 electrons as neutral. Now look at hydrogen. Hydrogen is in group 1, so it has 1 electron. How many electrons does it have over here? Well, the oxygen, it has 1 bond, so the oxygen took 1 electron and it has the other one. It has 1 electron. And we know free radicals are neutral. So that means it has a 0 charge. Let's do a negative charge just so you can understand what I'm saying here, okay? Now here's an alk oxide, right? Look at this oxygen. It has 6 lone pairs of electrons. It looks, if I take this out, right, all this on the bottom here, doesn't that look exactly like this? Doesn't that look like a free radical right there? It has 6 electrons around it, just like that. So if it was like that, that means it's neutral, right? But it's not like that. It has a bond. And that bond is 2 electrons, and it gets control of one of those electrons, right? So if this is neutral, and I add an electron, obviously it's negative. Look over here. Here's a hydronium ion. It's a water molecule that had 2 lone pair electrons, and a proton jumped on it, right? And jumped on one of the lone pair electrons. Now it only has 1 lone pair, okay? If you look at the oxygen, you know it's in group 6, so it has 6 valence electrons to be neutral, right? How many does it have? Well, it gets all those bonds. One of those electrons is this, and you know, so there's 3 bonds. That's 3 electrons. Plus, it has 2 right there as a lone pair. It has 5 electrons, and we know if it had 6, it would be neutral. So we took an electron away. It obviously has to be positive, right? If I took 2 electrons away, it'd be positive 2. So you see what the formula is saying? It's saying, hey, let's use oxygen as an example. It's saying, hey, I'm in group 6. So 6 electrons means I'm neutral. How many electrons do I have? And that's all you're doing. You're counting up the non-bonding electrons, 1, 2, 3, 4, and you're counting up the bonds, because each bond shares one of those electrons. So you want to know how many electrons does that oxygen have. It has 1, 2, 3, 4, 5, 6. And you want to know how many electrons it takes to be neutral. It's in group 6, so it needs 6 electrons to be neutral. Same over here. It needs 6 electrons to be neutral. How many does it have? 1, 2, 3, 4, 5, 6, 7. It has 7. 6 is neutral, then obviously 7 is negative. Over here, it needs 6 electrons. 1, 2, 3, plus these, 4, 5. It has 5. It has one more. It has 1 less electron than it should have to be neutral, so it's positive. That's what the formula means. And that's why you're counting all these electrons or whatever. You're just comparing. You're comparing how many it has when it's neutral to how many it really has. It has 6 to be neutral. How many does it have here? It has 6. It's neutral still. How many does it have here? It has 7, so it's negative. And how many it has here? It has 5, so it's positive. You're comparing how many it has now to how many it has when it's a free radical. That's it. Anyways, you all have a great day. Always remember, science is great.